Hey, it's Mrs. Weethy back for video lesson number 12 on scientific notation, which for the most part will be review for most of you. So scientific notation is used to express a very large number or a very small number into the following format, where m times 10 to the nth power. M is a coefficient and it's written using significant figures. So if your number, whether it's a very large number or very small number, has three sig figs in the format, then you must use three significant figures in the coefficient. It always has one digit, and this is really important, one digit to the left of the decimal. Now people, I noticed that when I check your video lessons, you need to get down examples. You need to make sure that you're getting down the things that I am stressing and, putting a lot of importance on. By the way, I'd like to introduce you to my little groovy, cool penguin friend. We're going to call him Rex. N is the exponent and can either be a positive or a negative number. If n is positive, then our number is a very big number. If n is negative, then we have a decimal number. Positive exponent is going to increase the number, so you're going to move the decimal to the right equal to the number in the exponent. Add zeros for placeholders, and if the zero is significant, then write a line above it. So let's take a look at that. Let's say that we have 2.00 times 10 to the fourth power. Now here's the thing. How many sig figs do we have in 2.00? Remember the zero rule. Zeros are significant if they follow a non-zero digit, and they do. And there is a decimal, and they do. So these two zeros are significant. So we're going to move that decimal to the right equal to the number in the exponent. So we're going to move it 1, 2, 3, 4 places. We have to add two zeros. So we would have 2, 0, 0, 0, 0, and we need to show that we have three significant figures. So putting a line on top of that second zero will show us that every digit up to including the zero with the bar above it is significant. And so our answer is 20,000 with that line above the zero. Okay, let's do that again, and let's say that we have 7.500 times 10 to the second. Again, you have a positive exponent, so we're going to make this number bigger by moving the decimal 2 spaces to the right. Put that decimal in, and we have 750.0. So we have 4 significant figures. Okay, negative exponent decreases the number. So now you're going to have a decimal number. Move the decimal to the left equal to the number in the exponent and add in the zeros for those placeholders. So let's say we have 2.00, but now that is times 10 to the negative fourth. So we want to make this number smaller. We're going to make it in decimal. We're going to move that decimal 1, 2, 3, 4 places to the right. 1, 2, 3. Oops, one more. 4 places to the left, excuse me. And then we're going to put in the zeros as the placeholders. I did that wrong. Let me start over. 2.00 times 10 to the negative fourth. So we have 1, 2, 3, 4. Put in the zeros. I wasn't counting the 2, moving the decimal before the 2. So our number is 0.0002. Now what you have to do, make sure that you have those 2 zeros after the 2 in there because they were part of the coefficient. So you had 3 sig figs. You need 3 sig figs in your answer. Okay, those are not place-holding zeros. Those are actually significant digits. So if we take a look at 750, 7.500 times 10 to the negative second, move that decimal 1, 2 to the left, put in our place-holding 0. Got to keep in the 2 zeros after the 5 because they are significant. And this is our number in long notation or common notation. Now, let's do just the opposite. Common notation into scientific notation. We're going to move the decimal place so that there is only one digit to the left of the decimal. The number of places moved is equal to the exponent. Okay, so let's take a look at this. If you have a positive, if the decimal is moved to the left, positive exponent, the exponent will be negative if the decimal is moved to the right. So if we have a number, let's say we have 50 with a decimal point. Now that decimal point tells us that that 0 is significant. Now we have to move that decimal one space because we want one non-zero digit to the left of the decimal. So we would have 5.0 times 10 to the first power because we only moved it one space. Let's say that we have 100,000 and we have a line above the third zero. We're going to move the decimal. We need one digit to the left of the decimal. That's going to be the 1. So we have 1, 2, 3, 4, 5 spaces we moved. 1.000. Now we need the 3 zeros because the line, you have a bar above that third 0, times 10 to the 5th, since we moved it 5 places. Now, if we have 0.0000230, we're going to move that decimal until we have one non-zero digit to the left. So we want the 2 to be to the left of the decimal. So we have 1, 2, 3, 4, 5, 6 spaces we're going to move that decimal. 2.30 times 10 to the negative 6th. Okay? That is it for video lesson number 12. Until next time, this is me, Mrs. Wheathy. So long for now.